Hello everyone and welcome to PA Academy. So in this video, we're going to be looking at CAM profile diagram. And basically what I want us to look at is how to answer questions under this particular topic, CAM profile diagram. So I won't be going through what is CAM, what is profile, what are the types of CAM, and what are the types of follow and what have you. We won't be doing that in this video. So let's just go straight to the point on how to answer questions under this topic. So if you are new here, please consider subscribing. You just see at the lower right of your screen, you see a red icon with subscribe. So kindly click on it to subscribe to the channel, PA Academy. Alright, so thank you very much if you have just done that. Alright, so now let's get started. Now to answer questions under CAM profile diagram, there are certain things you have to pay attention to in terms of the keyword. So one of them is number one, rise. The second one is dwell. And then the third one is fall. So these are the three things that usually happen. Is either the thing is rising, it's either it dwells or it's fall. Either they want to polarize it or they put it in singular, whatever one. So now when they say something rise, so you have something like this. That means it's going up. It's self-explanatory. That is rise. Maybe from a particular point it's going up. That is rise. Exactly. So when it is dwell, that means it's going on a straight horizontal line. Exactly. So that's it. That's this rise. This dwell is going on this horizontal line. It might be with a particular distance from here to here, or just horizontally somewhere here like this. It's just going horizontally. Then when it is fall, it's coming from an height and it is falling. Exactly. So those are the three things they use to describe it. Now under these three things, when it is rising or falling, there's another two things you have to pay attention to. How does it rise and how does it fall? Now, does it rise with uniform velocity? Does it rise or fall with, number one, I hope you're seeing this, with uniform velocity? Uniform velocity. The second one is either does it rise or fall with simple harmonic motion? Simple harmonic motion, SHM. Or does it rise and fall with uniform acceleration? That is the rise, uniform acceleration or deceleration. So that's uniform acceleration. So when it is uniform acceleration, that means it is rising, or deceleration, that is when it falls. So these are all the things that if you can understand some of these things, then you'll be able to answer or draw any question under this CAM profile diagram. So when it is rising, it is going on. When it dwells, that means it's going on an horizontal line straight. And then when it falls, that means it's coming down from a particular height. Now if it is so I'm just going through this again. If it's uniform velocity, now let's pick them one after the other and then talk about it. So let me just clean this. So now let's just draw this. Now when it is uniform velocity, now if you check page, what's it called? I think it's somewhere in the manual, so page 48 or thereabout. So depending on the question, let's just take a random okay, let me just make reference to the question 5. So let me just, I'm still going to talk about, I think I talked about this in the previous video. Once you see the question, just pick the important things there and leave the story behind. It says for 150 degrees crankshaft rotation, it rises for 30 mm with uniform velocity. So now let me use it to explain. It says for 150 degrees. So let me just take this place to be my 150 degrees. Or let me just explain this straight away instead of just picking a random point. Alright, so once you have your horizontal and your vertical line, what you have to do is you divide this into 360 degrees. Now you can use a scale that is convenient for you. I'm still going to do a real drawing, so let's just pay attention to it. So if you want to do maybe 1 centimeter represent 30 degrees, or 1 centimeter represent 15 degrees, or 2 centimeter represent the scale, the decision is yours. So let's just say this is 30, 60, 90, 110, right? Sorry, 120, 150, 180. This will be 210 and 240, and it continues like that. And that question says for 150 degrees camshaft rotation, the follower rises 30 mm. So let's take this to be our 30 mm. And the key point there, it rises with uniform velocity. That means from the origin, from the starting point to 150. So that means at this particular place, it rises with uniform velocity. Now, once they say something rises with uniform velocity, just pick it from where it starts to where it ends. Your ruler, join it straight. So this line here is where it rises with uniform velocity. Just a straight line from this point here to this point. Remember, according to the question, it's for from 0 to 150 degrees. Exactly, it could be anything on this axis, on the x-axis. So once it rises, just join it like that. If it is fall, so let's say, for example, the question now went further to say that, okay, from 150 to, let's say, 210, it falls with uniform velocity. Just pick it from those points straight to 210. Exactly. So that is it on fall. On fall or rise with uniform velocity. So I hope that is clear. So now let's look at the second one now, when it says simple harmonic motion. So if you check page 50 of the manual, I think you can see it. I hope you can see it. Just check page 50 anyway. Page 50 of the manual, you see it there. So now let's talk. Now we've talked about this with uniform velocity. Now let's talk about simple harmonic motion. Now let's still make reference to 0 to 150 degrees as an example. So this is the height and then 150. So we are told that, so let's take an example like, okay, from this 0 to 150, it rises with simple harmonic motion. So how do you go about to do it? And don't forget, this simple harmonic motion and uniform acceleration and deceleration, when it is rising, it's always like this, like ogive. This is when it is rising. And when it falls, so this is when it falls. So exactly. Now the curve looks similar, but how you are going to go about it is different. That's for simple harmonic motion and uniform acceleration and deceleration. So now I'm talking about simple harmonic motion. Now for it to rise, so what you are going to do, the first thing you are going to do is, once you have know the space that covers that either rise or fall, don't forget, like from for this particular example now, from 0 to 150, this is the space where it rises. So what you are going to do is, you are going to divide it into 6 equal parts. Now, depending on the scale that you are using, you can easily divide. Maybe you put in your ruler and then you divide it into by 6, and then you get a whole number. It is much more easier. Let's say, for example, maybe when you make, depending on your scale and the degrees that you are giving, if you should measure from here to here, you are getting maybe 6 centimeters. Definitely, you can just bring in your ruler and divide it into 6. Exactly. But if that's not the case, then you use the line division method. So you can pick it from here or from here. So I've done a video explaining this, and we have been taught in class too. So just at any convenient angle, you draw a line. So this is when you are only applying line division method if the distance from here, the length from here to here is not divisible. It's giving you some numbers that you can't actually divide. So at any convenient angle, you draw a line like this, and then you bring in your compass. So you place it here, you divide it into 6 like this, and then you do that into 6. So let me just assume that this is 1, 2, 3, 4, 5, 6. Now we are talking about line division anyway. So what do? From this point here, you join it here. Then you bring in your set square, and then you transfer the line. Okay, maybe when we are doing the real practical, I'm going to explain it. I'm trying to pick my set square. So you draw this line to be parallel to this. So with this now, where it is touching this line, I'm going to draw a line straight down. So we've divided it into 6, and it's a rough sketch, so don't look at it that they are not equal. So this is 1, 2, 3, 4, 5, 6. So you first of all divide it into 6, or vertical lines to divide it into 6. So I haven't done that. Now all these things will be with faint line. You have to pay attention to that. Then at the side, you can draw it at the end of your 360 degrees if you continue on this scale. But you can just do it at the side. That's if you are using faint lines. If you don't do it at this side, you can just use faint lines, because this is 150. So, definitely something else is going to continue here. So, but let me just pick it here. You draw a semicircle here, and then your semicircle, you divide it into 6. So again, if you don't know how to divide a circle into 6, listen. Once you get these points, exactly, with the same radius that you used to draw your circle. So like this. So with the same radius you used to draw your circle, like this, you bring it here, you draw an arc, you also bring it here, you draw an arc. With that same radius, you place it here, you draw an arc, and then you draw an arc here. So that's how you divide it into 6. But you have to make sure that this line, this horizontal line, is straight. Exactly, it's parallel to this, and it's dividing the circle equally. So with this now, you've been able to divide the circle into 6 equal parts. Now the next thing you're going to do is, now all these things I'm explaining, the steps are already in the manual. If you check that page 50 anyway. So now where this line is touching the circumference of the circle, you're going to draw a straight line. These lines are not straight anyway, but let's continue. So you're going to have something like this. So don't forget, we are talking about how to draw the rise when you are asked to when you are told that the thing rise with simple harmonic motion. So this is how you go about it. Now, then the point that you are going to pick now is this point, this, and this. So those are the points that you are going to use your French curve to join. So it's not going to be straight, it's going to look like this. Now you might be wondering, how do I get those points? Now let's do it like this. If you have divided this into 6, so let's call this, so let me draw it, let me write it. This is 0, 1, 2, 3, 4, 5, 6. And then let's call this 0, 1, 2, 3, 4, 5, 6. Remember, it's those horizontal line. I'll number it 1 to 6. So this is 6, this point here. So let's call this is 6 to 0, then 5 to 1, then 4. Line 4 and then line 2, where they are meeting. So I hope you get that. This is line 3 vertical, line 3 horizontal, then line 2 vertical, line 4 horizontal, line 1 vertical, line 5 horizontal. So if you do it like that, you get that point. Exactly. So this is how you go ahead with simple harmonic motion for rise. Exactly. So if you want to do that of dual, also, is also the same process. Exactly. You are going to go through all of these things. The only difference is how you are going to pick your points. So if it is fall, exactly, if it is fall, the point you are going to pick is going to be 0, 0, 1, 1, then 2 vertical, 2 horizontal, 3 vertical, 3 horizontal, 4 vertical, 4 horizontal, then 5, 5. Once you are picking the point, it will be pretty much straightforward. Then it will look like this. Exactly. So that is it on simple harmonic motion, either for rise or dual. This is how you go about it. Now the next thing I want to talk about is for the uniform acceleration and deceleration. So if you check page 52, like I said, the curve will look similar, but how you are going to go about it is what is different. So let's quickly look at that. So before we look at uniform acceleration and deceleration, I remember something while cleaning up that example. Now you see all those constructions that you are seeing, those vertical lines, the horizontal lines, the line divisions. Please, those lines are going to be with faint lines. They are construction lines, so they are meant to be thin lines. Exactly. So they are meant to be thin lines. The only thing that should be bold or should be visible is that curve itself. Exactly. So the horizontal line, the vertical line, the line division, those things are going to be with faint lines. So you have to pay attention to that. So now let's look at the third one now. So we looked at uniform velocity with simple harmonic motion. Now let's look at uniform acceleration. So once the question is telling you that it rises with uniform acceleration, definitely it's going up. Now let's pick this as an example. Let's say this is a question and says that, okay, from 0 degree to 150 degrees, it rises with uniform acceleration, and then from 150 to 210 it dwells. That means it goes on a straight line like this, and then from 210 to 360 it falls with uniform deceleration. So let's just use that to explain it. Now on this part is where it rises with uniform acceleration. Exactly. So the first thing you have to do is, now if you check the page 52 of the manual, first divide it into 4 quadrants. Exactly. So you divide it into 4, you measure from here to here, you divide it into 2. Exactly. Look at the height also, you divide it into 2. So you're going to be having 4 quadrants like that. So the next thing you have to do is, where you are going to, if it is rising, you are just going to be working with this quadrant and this particular quadrant. Exactly. So what you are going to do is, you are going to divide it into 4. Exactly. So you are going to divide this into 4. That is from here to here. You are going to divide it into 4. Again, if depending on the scale or the length is something that you can divide into 4 places easily. So let's say, for example, maybe it is 2 cm, that means it's going to be 0.5 each. If it is 4 cm, that's 1 cm. It is easy to divide. But if the reverse is the case, then you can then go back to your line division, where you draw a line at any convenient angle, then you divide it into 4, 1, 2, 3, 4, then you join it to the last one, then you have something like this. So where it is touching this line, you draw vertical line straight up. So you're going to be having something like this. So I've divided this part into 4. Also on this part here too, you're going to divide it into 4 also. So again, if it is not divisible by 4 easily, you go back to your line division method. So let me just divide this also into 4. Now don't forget, I said these things are going to be faint lines. Exactly, they're going to be faint lines. So what you want to do is, from this point here, now you can decide not to draw this horizontal line, exactly, but you can just note it on this, where it touches on this line, on this particular line. So you can just note it, because I don't want it to be too rough. So from here, you draw a line from this point here to come and touch it here, from here to, from here, and then to this point. Exactly. So let me make it more clearer. So like I was saying, if you have divided this into 4, so this is 1, 2, 3, 4. Now for the horizontal one, you are going to draw it. Now for the for the vertical lines, you just draw it, but don't forget they are faint lines. Then for the on this part, to just indicate it on this line. Exactly. So what's going to divide it into 4? Because you already have, this is 1, 2, 3, 4 already. So now from this point here, you just draw a line to touch here. So they are going to be straight lines. So now we are going to, what we've done here, we are going to repeat the same thing, but in opposite direction. So for the horizontal, to just note where it is divided this into 4. So this is 1, 2, 3, 4, exactly. And then the vertical lines too. If you are going to use line division method, let's say from here to here is not straightforward, you can't divide it straight away. So don't forget your line division. So you draw at any convenient angle. At any convenient angle, then you divide the line into 4. You join the last one to this point, and then you draw parallel lines. So where this lines is touching the edge of this place, you draw it straight down. So if you follow this, you are going to divide the line. You are going to divide this into 4 equal parts. Exactly. So now from this edge here, from this point here, you draw a straight line to touch this point. Are we good? So now how do you go ahead and pick your point? It remains 1. So now the next thing now is for you to pick your point. Now let's call this point, I hope you are seeing it. Okay. Alright, so what we are having here is what I've just drawn here, so that you can see it properly when picking points. So like I said, so from this point here, you draw a line here. So if you are finding value in this video, please give it a thumbs up, click on that like button, and don't forget to subscribe if you are yet to. Alright, so the next thing now is how to pick the point. Don't forget, we are looking at uniform acceleration. Exactly. Now for you to pick your point, so let's call this, let me just call this 0, 1, 2, 3, and then 4. 1, 2, 3, 4. So this is going to be, this point is included already, where we are having this line, this vertical line 0, and then the horizontal line 4. Their point of intersection right here is one of the points where we are having the vertical line 1, this line 1, and where this line, this line 3 is their point of intersection, which is right here. Exactly, this is the next one. The next one is on the vertical line 2, and where this 2 is, this point 2, the line that is coming from point 2, their point of intersection, which is right here. And then this line 3, and then line 1, their point of intersection, which is right here. And then the last one is going to be this point here. So that's what you are going to join together. Then for this point here, so let me call this 0, 1, 2, 3, and then this line here, let me call it 4, and then let me call this 0, 1, 2, 3, 4. So now let's pick up our points from here. Let's start from here. So this is going to be our first point here. Exactly. This point of intersection is definitely going to be one of them. So the next point of intersection is where we have this point 3, and then vertical 1, 3. This is going to be the point of intersection. Exactly. So this 2, this line 2 here, and this vertical line 2 is going to be one intersection. This line 1 and the vertical line 1, this is it here. And then the last one is just going to be this. So at the end of the day, if you join them together, you're going to be having something like this. So if you look at it closely, it's to give you a curve that looks like this. And that's how to do uniform acceleration. Exactly. So don't mix up uniform acceleration with that of simple harmonic motion. You have to know the two. Exactly. You have to know the difference between the two. All right. So what we've just done here is the rise part of it. I hope you can stay. Okay. So this is for rise. This diagram we are seeing is when it is right, when it rises. Exactly. But when it falls, with that's with uniform deceleration. So that's what I want to explain on this part here. So what we are going to do is just like you are doing the opposite of it. You are mirroring the, if you mirror the image. Exactly. So now let's just use this. So let's just take this. Let's say this is our 210, and then this is our 360, and we are told that it falls with uniform and deceleration. So definitely we are only going to be working on this part of the quadrant and this part of the quadrant. Exactly, on this part of the quadrant and here. Exactly. So again, we are going to divide it into 4. That's vertically. So let's start with this. So I want to believe by now you've already gotten the concept of how to divide it into 4. Then you take note of the division from here to here also into 4 equal places. So let me just assume this is it here. Exactly. So now from this point, this time around, exactly, unlike when we are doing rise, we pick it from here to all those points, but now from here, from the right, so you're going to be having this. Exactly. So what we've done here, okay, so let's do this also before we pick the point. So here also you divide it into 4. So this line is not straight at all. So you divide it into 4. You also take note of, you divide this point from here to here into 4. So let's just assume this is it here. Please don't assume, just do the right construction. And then from here also, so you draw this. So one thing you have to just take note is that you see this bent line is coming to the center of this line that divides the entire thing into 2. Exactly. Just note when you know that it's coming to the center, so you will not be confused with, is it coming from here? Is it coming from wherever? Just know that it is coming to the center after dividing into 4 quadrants. Exactly. So the next thing now is to pick the points. So if you follow what we did here, you don't have problem with picking the point. So for this particular one here, just know that this point of intersection here is 1 point. Then you keep tracing it down through the middle. That's another way to pick the point. If you don't want to use this number method, this 0, 1, 2, 3, 4. So once you pick it here, it keeps just follow the center. This will going to be the point. This will be the point here. This will be the point and the last one. Exactly. Then for this also, this will be the point here. You're going to be having Alright, so I just adjusted the lines here, they seem too close. Now from here I said to keep falling in at the center. If this is the point here, the next one is going to be this. It's going to be this. By default, naturally you should be able to get it. Exactly. Just keep falling into the center. Then you can then join it. So you are going to be having it. So you use your French curve. So you can see at the end of the day, it will be forming a curve. So don't forget, when I said when it is rising, it rises like this, and when it is falling, the curve will look like this. Exactly. So basically, this I've spent so much time. This is about 25 minutes. What I've been explaining since morning is just the displacement diagram. Exactly. This is just the displacement diagram. So in the next video, I'm going to be explaining how to draw the cam profile. That's one with circle, and then you have something like this. I think I'll be doing that one in a separate video. So I hope you find value in this, and I hope you understand the concept on the displacement diagram. So if you have any question, just leave it in the comment section. I'll respond to them. And then don't forget, if you are yet to subscribe, please click on that subscribe button, and then I'll see you all in the part 2 of this video. Thank you.